The code is down here at the bottom. So just find what cosecant is equivalent to. First one, just look at your trig identity list, either in your notes or if you want to pull that chart up. And this one really you should actually know. So remember what cosecant and secant, they kind of match with the one you wouldn't think they would. You would think cosecant and cosine match, but it's the opposite. It's cosecant and sine. So cosecant is 1 over sine. Cosecant 1 over sine. Alright, so this is one of the trig identities. It's a Pythagorean identity. Anytime you see like a square and a 1, it's probably a Pythagorean identity. Whether it's a sine, cosine, tangent, secant, something like that. And it's a square and a 1 or negative 1 or minus 1. It's got to be an identity. If you look at our Pythagorean identity here, 1 plus tan squared, 1 plus tan squared equals square. So that would be secant squared. This should be an easy one you have to memorize. Notice the order is just a bit different. On our sheet it has sine squared plus cosine squared. That's generally how it's written. But in the order that you wrote it down. Same here. Sine squared plus cosine squared. Same as cosine squared plus sine squared. That one you should just know by heart. Make sure you pay attention. This one's also on your sheet. We're going to do some hard ones here. This one you should also probably have memorized, sine over cosine. We use this a lot, even when we did the unit circle. Here's there. Right here, that's a quotient. Alright, this one you gotta do a little bit of work. So you can probably think of which one you're going to replace, cotangent, right? And then see what cancels. Cotangent is cosine over sine. Then you should get a nice cancellation, and then whatever you're left with. See, the sine, since they're opposites, this would be the same thing as sine over 1, that cancels each other position for cosine. Do similar substitutions. Figure out what secant is, what cotangent is, and keep the sine, but you'll replace these two with sines and cosines. Over here. secant is 1 over cosine. Cotangent is cosine over sine. Sine is sine. And what happens is, well, these two cancel. These two cancel, so these are just 1. Now this one's going to be a little bit harder. What do you guys think should maybe be the first step on this one? You're gonna have to distribute. So whether you do distribute first or second, you have to distribute it. Maybe change this into something else. Okay. Keep the signs, distribute this. So if you just distribute right off the bat, you get sine times cosecant, and then sine times sine, and then sine squared. You can then replace cosecant with 1 over sine. You can also switch this one if you want. And then when you do this, sine times 1 over sine, these cancel. So it leaves you with 1 minus sine squared. Now this is one of our trig identities. Just rearranged, right? The sine squared plus cosine squared is 1. So you would then just subtract your sine over. So it's equivalent to cosine squared. So you use that one a lot. So make sure you're familiar with how that rearranged. Alright, so this one you got a foil. It works out pretty good though after you foil the first one. Secant x minus 1 and secant x plus 1. I did several like this last Friday. It's been a while though, I know. Well, you should get secant squared x. Your outer and your inner are going to end up canceling because it's the minus and plus secant x. Minus 1. So these two canceling, secant squared x minus 1. Secant squared x minus 1. Secant squared x minus 1. And then find the Pythagorean identity that fits secant squared minus 1. Anytime you have a squared and a plus or minus 1, really can figure it out. And if you take this one, let's just subtract it 1 over tangent squared would equal secant squared minus 1. Tangent squared. Now with this one, what I recommend is replace these first two right off the bat. Okay. Don't worry worry about replacing that cosine squared yet, but replace those first two. See what cancels, and then see if you have a trig identity left. So when you replace these first two, they're reciprocals, tan and cotan. These cancel and these cancel, so there's just 1 minus cosine squared. That's cosine squared is equivalent to sine squared. So the question is, basically, could you make that a Pythagorean identity? Tan squared plus 1 equals secant. It might not be exactly what's written, but is it a Pythagorean identity? Would that be true? If you look here, it's not exactly what it says, right? But it's the same thing, just you switch the tan and the 1, and you're allowed to switch those. It's addition. You can rearrange those. Oh, it is there. That might be true. I wonder if on the game I just forgot to put that there. Find out. Yeah, so I think I'll have to edit the game, but on the game, that should be a squared. If that was a squared, it'd be yes, but it's not, so that's why it's no. Maybe I'll change that one. That's kind of a trick. So. Replace both of those in terms of sines and cosines. Sine over cosine times 1 over sine. There, cancellation. We have 1 over cosine, and that's equal to 1 of these. Then what is 1 over cosine equivalent to? That's one of our reciprocal identities, which is secant. Right now. Wear sunglasses. So this one, you will want to distribute it. Yeah, there's a couple ways you can do it, but I probably want to just distribute first. So our first step, when you distribute, you should get cotan squared theta, and then plus cotan squared tan squared. Now you should note that those are reciprocals, right? Cotangent, tangent. Okay. So these actually would just cancel, give you 1. The reason why is this would be cosine squared over sine squared. And this one would be sine squared over cosine squared. Yes, they just cancel out. So that's all just one. So we got the cotangent squared plus 1. See if we can make background identities to work for that. Anytime you have a squared and a 1, generally there's some way you can get that to work out background identity. And see, it actually is 1 cotangent squared. Okay, so a lot of this is just practice, figuring out when to replace y. Probably want to replace those first two, right, with sines and cosines. Just cancellation, see what we got left. Should look something like that, right? Sine over cosine, 1 over sine. These cancel. And then when you multiply together, these actually cancel too. This one might be a little trickier. I'm not going to give you any hints just yet. We'll try to figure this one out. There's a couple ways you can solve this. Nice try. Oh, okay, let me cancel the timer. I'm about to give you the least amount of time on this one. Like I said, there's a couple different ways you can do this. I'm going to start to write out one of the ways. So there's 2 ways. So one way would be to split this up into secant squared over secant squared minus over secant squared. You can do that. You can just take this one over the denominator and this one over the denominator. It's not the only way, right? But there's another way to do it. This then just becomes 1. The same thing of itself. 1 minus 1 over secant squared would be the same thing as cosine squared. 1 over secant is cosine. And then 1 minus cosine squared would be equivalent to sine squared. So that would be one way to do it. The other way that you might have done is secant squared minus 1, if you look at your chart. You could just subtract the 1 over here and make that tangent squared. So you could do tan squared over secant squared. The other way you can do is you could then change tangent from sine squared over cosine squared over secant squared is 1 over cosine squared. And then you would keep the top, keep change one because you got fractions. So we keep the top, change it to multiplication and flip bottom. these cancel when you do this. So, some good ways to do that one. It is harder. This one you write a little bit less.
Either way, we get sine squared.
And last one, I believe here. Oh, I guess we got. So we got 3 more. Oh yeah, this one's a hard one too. Let's think before you answer it. What would be a good strategy to do for this one? Kind of like foiling. There's no multiplication. Notice how this is a cube. What is this one also having? What that cosine, right? Okay. This one's got 3 of them. So what you actually want to do is you want to factor out, like, pull out the greatest common factor. So if you pull out a cosine x, then you would be left with what would you be left with inside? If you pull out a cosine, what would you be left with inside of there? Yeah, you'd be left with. If you pull one cosine out of here, you'd be left with a cosine squared. If you pull this cosine out, you'd be left with sine squared. So cosine times cosine squared plus sine squared. This is an identity, so it's actually easy at this point. But you gotta just now go pull out that cosine. So this is equivalent to really easy, and then just multiply by cosine. I'm gonna say sine squared plus cosine squared is 1. So then you just have cosine times 1. Again, these just take a lot of practice. The only reason I know how to do that is because I've solved a lot of these problems. Cosine times 1 is last 2. This one looks hard, but if you just recognize what's going on in the first 2 there. So these first 2 end up just canceling. A tan and a cotan, those are reciprocals. So that leaves you with 1. It's just 1 minus cosine squared. Sine squared. Alright, last question. Which is not a Pythagorean identity. Let's see what I have. This is the future. And it's 12 inches away. Alright, make your choice there. Which one of those is not? Oh, you can't? Oh, doesn't let you answer when I did that. It's in the beta stage. I also have this fun feature. Of course, it doesn't actually have your real name, so it's nice. Alright. There you go. Congratulations. You can just like do it so you could like call on someone, hey, explain what the answer is.
Oh, that was good.
So the
I
answer.
think there was multiple ones that were wrong. Like, all of those don't seem like the other
Yeah,
two
there's
are-
-1.
Which is not that.
Like
Let's see here.
Like the first one, or no, not like the last two, those two, like, it doesn't make sense.
Cotangent squared minus cosecant squared equals -1.
It doesn't match up.
Okay, so they actually do work. So this one, if you were to subtract it over, and then you subtract this one over, it works.
But the one about the last one, but it's the
If you move that over, that works.
but then the one is just positive.
This one?
Yeah.
So cosecant minus cotangent equals 1.
Oh wait, yeah.
If you just subtract cotangent over, then it works. So they all work, except for the one.
That was actually wrong.
This was the only one that doesn't work. Cosecant squared plus 1 equals cotangent squared. That one does not work. You can get these other two by just rearranging the equation. Alright, that is the end. Good job. Hopefully your skills are not going to actually have 2 days off. Alright, let's see who won here. First few. Alright, let's do the first 3 because only missed none and then 1. Who is Rosemary? Alright, Eli. Asparagus. Nobody? Nobody wants. Alright. And then papaya. Alright. Very good. Alright. With the remainder of the period, you are going to be working. If you choose with a partner as well, you can do this with a partner. These are not going to be easy, I'll tell you that. Some of them are quite difficult. But you've got the period to work on it. There's also some that are really hard. I'm going to tell you to circle a few of them that are really hard. You will turn it in eventually, yeah. Probably tomorrow. But there is a few that seem almost impossible. They're not impossible.
Almost impossible.
Somewhere said
I love that.
to 100,000.
So at least you know this one's not going to be easy. It's suffer a little bit.
Oh, my boy is freezing.
All right, so let me point out just a few that are pretty difficult. Number 1 should be pretty easy. Number 2 should be, 1 and 7 should be easy. 2 is pretty difficult. So if you're struggling with that one, it's okay if you don't get that one done. I want you to still try it, but if you can't figure that one out, it's okay. Number 8 can be a little bit difficult as well. So I still want you to try these, but you might not be able to figure them out. Number 3 will be a little bit challenging, but I think you can figure that one out. Number 9's okay. Number 4 you should be able to get. 10's a little challenging, but you should be able to get it. And I think the other really hard one will maybe be number 6. Number 12, it's not hard, but it's tricky. So it's actually really easy if you can figure it out, but it's just tricky. There's only one step. So give those a shot. Work on those the rest of the period with someone. I'll see how far you guys get. I might have you finish it for homework, but I'll see how far you get. I'm not sure. So just work on it. And again, if you get stuck on these two, I still want to try to figure them out. But if you can't get them, that's okay. You have to do some fraction work where you have to get the same denominator. Remember where you like multiply by sign over sign, something like that. So just be aware of that. And actually, maybe I should do number 2 just to refresh your memory. I kind of set that one up. So on number 2, it's going to be sine of theta plus cotangent is cosine over sine. And also, if you prefer to write this on a different sheet of paper, you can do so as well. Depends how small you write. But on number 2, you would start like this. Just replace that one. You're then going to have sine theta plus cosine squared over sine. Then to combine these, what do you have to multiply this first one by? Yeah, sine over sine. Well, you have to do that to get the same denominator. So then we would have sine squared over sine plus cosine squared over sine. You then can combine them because they have the same denominator. So we get sine squared plus cosine squared over sine. Sine squared plus cosine squared is 1, so 1 over sine. Go from there. And then your answers for these, that's not going to be your final answer. You can do one more thing. There's going to be options down here. This is a puzzle. So your answer for this is 1 over sine, which is equivalent to cosecant, right? Your answer is going to be down there, so that's n. You can see down here is one of your options. So then you're going to go to number 2 down here and put an n. And it's going to answer this question on October 4th, 2006. Akira Haraguchi broke his own record by reciting the number pi to 100,000 decimal places. It took him over. Do not Google the answer, because I know someone will do that. Can't stop you from it, but you still got to solve all the problems. You're going to have to show even more work.